So, alrighty. So in this section, polymorphism, this is section 9.5 in Code HS. The word polymorphism, if we break that down into some of its root meanings, the word poly means many. And we've heard that word poly many times. Polygon, polygamy, which means basically a many-sided figure, having many spouses. Those are ways that we've heard of this before. So when we hear the word polymorphism, that means having many forms. And in terms of coding, if we have a polymorphic reference, that means that this variable can refer to different types of objects at different points in time. Now, you might be wondering how the heck that is possible, okay? Well, let's imagine, for example, what I have worn to work this week. If I were to have a variable that was called shoes, well, on Monday, I wore my black gym shoes. On Tuesday, I wore my gray gym shoes. On Wednesday, I wore my other black gym shoes. Apparently I like gym shoes, right? I think Thursday, I wore the same black gym shoes. And today I'm wearing the black gym shoes that I wore on Monday. They're all shoes, right? They're all subclasses of shoes. They are all examples of shoes. And because they are all, like if I think of shoes as a whole, shoes could be dress shoes could be boots, shoes could be flip-flops, shoes could be Crocs, shoes could be Uggs, shoes could be whatever you want, but shoes is a generic term. So if I had a shoe superclass, I could have subclasses of gym shoes, casual shoes, sandals, heels, boots. And then I could have whatever shoe I'm wearing that day, my reference could refer to that specific shoe. So this one variable, Dena's shoes, could refer to multiple specific objects. So that's what we mean when we say that we could have a reference variable that can refer to different types of objects at different points in time. The reference of Dena's shoes is still the same thing. They're still the shoes that are on my feet. They're all shoes. They're all subclasses of shoes. So I can say, oh, these are my shoes today. Oh, yeah, I was wearing different shoes. They're all shoes. I can use the generic word shoes to describe them. Whether I'm wearing boots or shoes or heels or whatever, they're still footwear. Okay. So the way that we saw this in our warm-up that we did today was we had the animal class, and our animal class had subclasses. And because cow and pig were subclasses of animal, so this was our animal class, and we had cow and we had pig, and within the animal class, animal had a method called speak. And so cow and pig, remember, cow and pig inherit those public methods. So anything that is an animal, we know that it can speak. We know it can speak because it has inherited speak. So either it will speak like an animal, or it will override that method and speak specifically like a cow, or speak specifically like a pig. But no matter what, we know that an animal can speak. So that was why we were able to say in our code, that was why we were, oh my goodness, I can't even spell. We were able to write animal A in barn. For every animal A in barn, we were able to say A dot speak. The reason why we were able to write this code was because regardless of what kind of animal it was, whether it was an animal, a cow, or a pig, we know that all of them have this speak method. Okay, so as we were going through that for each loop, what was actually occurring is the first time through A referred to an animal. The next time through A referred to a cow. The next time A referred to a pig. Then it referred to a cow. Then it referred to an animal, just like how my footwear changes every day. But because they are all animals, it works. And A can refer to anything of the animal class or its subclasses. Before I continue, does that general broad idea make sense? Okay. So the example that I have here, polymorphism via inheritance. So let's say we had a person class, and within our person, we had a subclass teacher. Every teacher is in fact a person, okay? So everything that we've done so far, we have always had the variable type match the constructor call. They've always matched. We haven't known anything different. If I had a teacher reference, it pointed to a teacher variable. If I had a person reference, it pointed to a person variable. That's all that we knew. However, I'm still a person, right? Mrs. Denna is still a person. So I can do this type of creation. I can have a generic reference refer to a specific object. Okay. Now it only works if that specific object is a subclass of the generic reference, because a teacher is a person, just like how a cow is an animal. And the really cool thing about this is what happens is when Java actually calls the methods for this APCS reference variable, it will call the method that applies to the specific object that was actually built. And the way that we know which specific object was built, we can tell this by looking at the constructor that was called. That's how you know which object was built. So in this first example, I can tell that I built a person object and stored the reference in a person variable. Here I can tell I built a teacher object and stored it in a teacher variable. Here I can tell I built a teacher object and stored the reference in a person variable. Any questions so far? Okay, so when we try to look at how we can make declarations, we want to make sure we understand what we can and can't do. So if we were to look at this diagram, let's see what would be legal. And remember, we can always do generic equals new specific, okay? That's essentially the rule that we need to remember. Generic can equal a new specific as long as it's a subclass, okay? All right, so I have this animal, and I'm trying to say that animal A equals a new fish. So what do we think? Can we do that? Yes or no? And just unmute and answer. What do we think? Yes or no?
Yes.
Yes, we can, because a fish is an animal. Since this is a specific example of an animal, that is okay. So I can do that. So I'm going to highlight that in green. So legal, we're going to say is green. Good news. All right. Plant B equals new organism. What do we think? Yes or no? Come on, you guys, speak up.
No.
Yeah, that would be a no. Good job. And the reason why this is a no is because organism is not a specific example of a plant. That's going the wrong way. Okay, so you want to say, are all organisms plants? Well, no, some organisms could be animals. So that's why this is a wrong statement. Okay, how about number 3? Organism equals new plant. What do we think? Yes or no?
Yes.
Yes, all right. All right, go ahead and try number 4 and 5, and I want you to send me a chat with your answer. And yes, a lot of people are saying no and yes. All right, so let's see. And then we also had a question, which we will take a look at too. So the first one, mammal equals new animal. That is a no. Nice job, you guys. We can't go backwards. And then the next one says organism equals a new organism. Yeah, we can do that. That's what we've been doing all year. We can totally do that. Now, the question that was asked in the chat, could we do organism A equals new fish? Great question. All right, so what do you guys think? Can we do that? We can, because a fish is an organism. It's just a really specific. So yes, we can totally do this. How about if I were to give you the equation or the question, plant P equals new mammal. What do you think? Can I do that? No, I can't do that. Mammals aren't plants. That would be a big fat no. All right. Before I keep going, where do we have questions? All righty. So if we continue on, I want to make sure we really understand this syntax, okay? So when we look at our syntax, we have the reference variable before the equals, and then it's equals a new object type. So it's important that we realize the reference variable can be generic, and the object type can be a more specific subclass of that generic. The other way around will not work. And then it's also important to realize that we can always tell what type of object was instantiated by which constructor was called. Okay, and this is our constructor, the part that's after the word new. And this last part is super duper important. The type of object determines which method is executed when methods are overridden in the subclass. All right, and we saw that when those various speak methods were executed in our warm-up. Okay, so we saw how depending upon what kind of object it was, determine which speak method was called. All right. Couple more things to clarify. There's like so many little itty bitty nitty details in this lesson. And that's why, like Manu was saying, if there's questions that come up or specific details, you want to make sure you ask. Like this question that was asked here about organism equaling a new fish, that was a fantastic question. That probably cleared up that question for many people. So please ask. I guarantee you will not be the only one that has a question, okay? All right, so this is what we worked on in our warm-up. We said that pig was a subclass, animal is a superclass. The pig object is actually built. It's stored in our generic animal reference. So we refer to the constructor to see what's built. It has to follow that is a relationship. So again, it only works when we're being generic. So if I were to try to go in reverse, this would be a big fat error because not all animals are pigs. So again, I just really want to drive that home. Now there's another concept that we talk about in polymorphism, which is early binding and late binding. So let's talk about what the difference is. Let's first talk about early binding. So early binding is when Java has to make a commitment to which method is going to be called, and that commitment is made at compile time. Okay, the method that is used is determined by the header of the method, the parameters, and so forth. This is going to happen when there is only one method that could be called. So we have no inheritance going on. There's no overriding. There's only one option. All right. The compiler looks at the code and it knows, oh, you're a pig. You're going to call the pig method roll in the mud. Or this is a string and the string is calling the method to uppercase. Easy peasy, no big deal. Okay. This happens when there is no polymorphic references. The reference type and the object type are the same. Okay. There's no confusion as to what's getting called. For some reason, my Zoom just stopped screen. All right, so as I was saying, this happens when there's no confusion about which method's going to get called. Now, on the other hand, late binding, this occurs when we have a polymorphic reference, like what we saw in our warm-up. The commitment of which code to run cannot be made until runtime. So as the code is executing, so like if we think about that for each loop that we had, so let me snag that code real quick, even though I wrote it sloppily. Let me just grab that and pull that up here. So as we look at this code that we had, if I think about how the computer is going to work through this, the computer is going to say, okay, I get the reference for the first variable. I find my reference A. I transfer myself to that object and I see what's there and, oh, it's an animal. Okay, I'm going to use the animals method for speak. I do my job. I go to the next value. I get the value from my reference variable A. I go to where that's stored in memory and, oh, you're a pig. Oh, okay. I'm going to use the pigs speak method. I do my business. I get the next reference for A and I get to where it's stored and, oh, you're a cow. Okay, I'm going to use the cows speak method. So in this case, Java doesn't know which code it's going to run. It has no idea which animal you've even made. It just knows that there's an animal or an animal descendant. Okay, this is what we call late binding. Java has not yet committed itself to know which code will be run. Okay, and this could easily be done. Let's say you had user input and you were asking the user, what kind of animals do you have? I have a cow. Okay, what's your cow's name? You enter it. What's your next animal? It's a pig. Okay, what's your pig's name? You enter it. What's your next animal? I have a chicken. Okay, what's your chicken's name? And you enter all these animals for the farm. And then when you're done, you have a method called animals speak, and then they all speak. You have no idea what the farmer has, and it doesn't matter because they can all call their own speak method. That's because of late binding. Okay, super, super huge, powerful feature that Java has, but it's important that we understand that the only reason this works is because we have a generic reference. Okay, so like in this case, I have a generic person reference. Here I have a generic animal reference. It needs to be a generic reference that can point to any descendant. Okay, so to kind of sum things up a little bit, let's see, for lack of not wanting to try to do too much in one day, let's scroll on down to this slide number 12. We're going to take a look at these last two slides because I feel like the next couple ones are a little repetitive. All right, so why is polymorphism so cool? So number one, it allows for a lot of flexibility in your code, okay? You can create an array list of a generic type, your superclass. And then when you create, oh, and ignore the word abstract class, we're not learning those this year. And then when you create the actual objects, the code will compile, okay? When the code is executed, the specific code for the actual object created is executed. This also means you really need to pay attention to what type of object was created, not just what the reference is. So you can always tell what kind of object is created based on the constructor call. And the reference variable can only call methods that are defined in the superclass. So even if you know that something is a more specific version of something, it doesn't matter, okay? An example of this, let's say your shoe class has a subclass called tennis shoes, and tennis shoes has a method called tie shoes. Well, not all shoes have laces, okay? So if you had your shoe that you were wearing that day and you tried to say shoe dot tie shoes, it wouldn't work because not all shoes can tie shoes. So this is what we mean by this, and we're going to work through this some more next week. And if we know that an object is a more specific type of object, we can first cast it to be that specific type, and then you can call those methods. And that's what our last slide is looking at. Okay, so our last thing that we're looking at here is the ability to cast a reference. And we're going to come back to this more next week. So I want to point your reference to it. But for right now, what I want to do is I want to open up and get started on worksheet 2 together to help you see how to kind of think through these problems. Okay. So what I want everyone to do on Schoology, you'll see worksheet 2. So go ahead and open that up, please. And we're going to work through some of this together with the remaining time, because I want to make sure you understand how to think through and process that. And I did put the answer key for this on Schoology. It is visible so that you can check your work. What I don't want you to do is just straight up copy. I'm sure you're smart enough to know that that's not going to do you any good. Okay. All right. So when we look at this worksheet, what I want you to recognize is that we have the class name, we have our inheritance structure, and then we have these methods. Now, remember with inheritance, the way that it works is that that method filters to anything below it. So for example, since eat belongs in animal, everything on this chart can eat. On the other hand, flap only belongs to bird. So the only thing on this chart that can flap is a bird, a chicken, or a sparrow. Okay. All right. Now we're supposed to mark these with valid or invalid. We're just going to use a V and an I. Make it easy on ourselves. There's no reason to be writing out the whole word here. Okay. So I'm going to walk through a couple of these with you to help you understand how to think about them. That way you're having a better idea of how to understand them. So if we look at number 1, we know that we can create an animal and an animal reference and an animal object. That is okay. We know that we can do that. So that would be valid. Now, when I look at number 2, and it says A1.eat. The way that I want to think of that is I want to say A1 to the computer, this is an animal, because that's what the reference says. Are animals allowed to eat? And I look up here and I say, yes, they can eat. Animals are allowed to eat. So this would work. So I'm going to say that's valid. Now I look at number 3 and it says A1.move. Well, remember, A1 is an animal. Are animals allowed to move? Can all animals move? No, they can't. So this is invalid. And I would also encourage you to write the reason why. Not all animals can move, because it will help you better understand the reasoning of what's going on here. Now, when I look at number 4 says, okay, I really want to call this move method. How about if I just pretend that it's a mammal? Can I just call it a mammal? Can I cast it as a mammal? Well, here's the problem with this. When I made A1, I made an animal. It's not a mammal. I can't cast it as a mammal if I didn't build a mammal. This is like me telling somebody, lace your shoes when they're wearing slip-ons. You can't do it. It doesn't matter how much they say, but they're laces. No, there's not. This is not a mammal. I cannot call it a mammal. This would be your illegal class cast exception. You cannot cast something as an object that it is not. So this here would also be invalid. And the reason why is because A1 was instantiated as an animal. You cannot cast it as something more specific. Questions so far? All right. Now, let's look at number 5, 6, and 7, because like I said, this is some tough stuff right here. All right. Like I said, this is a tough concept and we're going to work through it and everyone's going to struggle with it. I'm going to tell you right now, you're going to struggle with it. You're going to find it hard and you got to ask questions like Manu said. Okay. And I'm going to go right up to the bell today. And then I'm going to be posting this video so that if you need to, you can go back and rewatch it. It's going to benefit not only people that were absent, but also anybody that needs to rehear how we talked through these problems on the worksheet. So we look at number 5 and I'll switch colors since I know this is a little jumbly here. It says animal A2 equals new mammal. So remember, we're allowed to say generic equals specific. So animal is generic, mammal is specific, so that is okay. That is valid. Now, mammal M2 equals A2. Now, a lot of people want to say that this is valid because they're like, oh, but A2 is really a mammal. But here's the problem. Java has blinders on. All that Java can see is that A2 is an animal. Even though we know it's a mammal, it's disguised. Its reference variable is generic. It has a generic label, okay? It's kind of like saying this is a cup. I know there's water in here. I know what's in here, but it could very easily be scalding hot coffee. So if somebody took it and went, look, you'd be like, wait, you're going to burn yourself, but I know what's in here. You can't do that. So you can't just go and say mammal M2 equals A2 without knowing that A2 is a mammal. We don't know that. All we know is it's an animal. So this right here is invalid. And the reason why it's invalid is because Java only knows A2 to be an animal because that is what the reference is. And the bell's about to ring. Ah, there's the bell. But now when we get to number 7, this is valid. And the reason why is because now we're saying you can call it a mammal because it is a mammal. So you're allowed to cast it as a mammal. And once you cast it as a mammal, now you can save it in a mammal reference. So since A2 is really a mammal, and if you got to go, that's fine. I'm just going to finish this sentence. Since A2 is really a mammal, you can cast it as a mammal and then save it in a mammal reference. Whew. All right. So our homework. We've got this worksheet 2, which is this guy right here. We want to complete it, check our answers. And then there are 2 programming assignments on CodeHS. They're listed, this is all listed on the agenda, but for next class, I definitely want you to have this worksheet done, okay? If you can't finish both, at least get the worksheet done. Have a wonderful weekend, you guys.